Okay, we're going to start today off by talking about complex numbers. And you've probably seen this before. I've had some people asking me about it, and I'm going to go off on a little tangent before we get into the actual lesson. A little background knowledge. So you've probably seen the lowercase kind of cursive looking I somewhere. A lot of people have seen it on the practice ACT or the real ACT. So we're going to start talking about what this I is. So it's an imaginary number. Yes, it is a number. I know it looks like a letter, but it is an imaginary, and actually it's called the imaginary unit. That's the technical name. And the definition of this is that I squared is equal to -1. Yes, that's the definition. I squared is equal to -1. So you're probably like, Mrs. Roeder, you can't have something squared and it be a negative number. Well, this is the one time that you can. So when we use these i's a lot, is another definition you might see is that I is equal to the square root of -1. So anytime you take a square root of a negative number, so let's say the square root of -4, this answer will be 2i. Okay, so that's when you'll see it, or the square root of -16 will be 4i. Okay, you always write the I second. Okay, it's the constant, or the coefficient needs to be the real number. Okay, so let's talk about some properties of I. Okay, so I plus I is going to equal 2i. Okay, there's that. So that's kind of the same. You treat it like a normal variable. Where it is different is, okay, so I to the first power is just I. Or sorry, not 1, is just I. I to the second power, if you remember, I just said in our definition, I to the second power is -1. So I to the second power will be, -1. All right, let's do I to the third power. That will be like I times I squared. And we said I to the first power is just I, so this will be like I times I squared is -1. So that's equal to -I. Let's do it again. We could do I to the fourth power. That would be like I squared times I squared. So that would be -1 times -1, which would equal +1. Okay, so I to the fourth power is +1. Okay, so I would definitely keep these things in mind. We're going to be using these a lot today whenever we're doing this. Okay, so let's get started with our first problem. Actually, I take it back. So whenever I'm going to go off on another tangent, I'm sorry, this video is probably going to be pretty long. So if we have a number like 1 divided by the square root of 2, if we have a fraction, the proper term, you never want to leave a square root in the denominator. They always want you to rationalize the denominator. It's just not proper. So you would multiply it by the square root of 2 over the square root of 2. So this would be the square root of 2 over square root of 2 times square root of 2 would be 2. So when you rationalize it, so you're going to do the exact same thing with these imaginary numbers. So if you had, for example, let's just do 1 over I. So you don't want to have your I in the denominator, so we're going to have to rationalize it. So this would be, you have to multiply it by I over I, and we can do that because I divided by I is 1. Anything divided by itself is 1, and you can multiply something by 1 and it doesn't change the value. So this would give me I on top, and on bottom you would have I times I, remember, is -1. So you could leave it, actually let's not leave it like that. That would be -I, because I divided by -1 would be -I. Okay, so we don't want to leave the i's in the bottom, and let's get started. That's the main thing of this. No i's in the bottom. Okay, so for this, we're gonna rationalize this. So first, let's get rid of that 8/10. We can make it a fraction 4/5. I'm going to make it a little bit easier on this. Okay, so now this is 4 over 5i, and I need to rationalize the denominator. So I'm going to multiply it by I over I, because that'll get rid of my denominator. So, or the I in the denominator anyway. So that'll be 4i over 5 times -1, which would be 4i over -5. Or you could bring that negative out front. Doesn't matter. Okay, let's do another one. We got a binomial on top. Don't freak out, you'll be all right. So we're going to multiply it by top and bottom by I over I. So I'm going to have to use the distributive property on the top section. So it'll be -7i plus 7 times -1, because I times I is -1, over, and that would be 7 times -1 now. All right, I'm going to clean it up a little bit. So I would have -7i minus 7 divided by -7. As you can see, there's a ton of 7s on this problem, and we can simplify. Remember, if you're simplifying something like this, it has to be to all 3 terms. It can't just be for 2 of them. And in this case, it works. So if we divide everything by -7, that gives me +1. Actually, I'm going to write it a different way. So that gives me +i plus 1. Okay, so another thing I haven't mentioned yet, you want to write this as 1 plus i. Kind of like whenever it's the right way to write a square root, whenever we were doing that in the last couple sections. Write the square root last, you want to list the I last as well. Okay, let's do another one. So we're going to multiply the top and the bottom by I again. That would give me 5i minus 9 times -1 over 8 times -1. So that would be 5i plus 9 over -8. Can I simplify that? Nope. So one thing I haven't mentioned yet is they want you to break this up. So you can break this up into 2 fractions, and this one we have to because there's 2 terms in our numerator. So this would be the same thing as -8 on bottom. I'm just going to bring that negative out front. So negative 5i over 8 plus 9 over -8. So am I done? No, I'm really close. Unfortunately, we just need to switch those over because remember, you're not supposed to have the I term be your first term. So that would be -9/8 minus, I'm just going to, instead of putting a plus sign there, it's kind of silly, let's do -5/8. All right, 5i over 8. Okay, now letter D. We're going, on this one's a little bit different. We're going to have to multiply by what's called the conjugate. So the conjugate is this. So you look at the denominator, and this one's 3 minus I. So we're going to do 3 plus I is the conjugate. Why did I put an equal sign? I didn't mean to. So we're going to multiply it. So it's going to be 3 plus I over 3 plus I. And you'll see why I do the conjugate in just a second. So I'm going to go ahead and do the numerator. So that would give me 3 plus I over 3 times 3 would give me 9. 3 times positive I would give me positive 3i. Negative I times 3 would give me negative 3i. And negative I times positive I would give me negative I squared. So as you can see, I did this because look what happens right here. What do you know about those 2 terms? Well, there's one positive, one negative, so they're going to cancel. Sweet. Gets rid of some of my i's. So I still have 3 plus I on top, and now I have 9 minus, and I squared would be -1. So that becomes plus, so this answer, we're getting closer, is 3 plus I over 10. Remember, we need to split it up and put the I term second, which on this one it is. So you can, let's write it as 3/10 plus I over 10. And that would be your answer. Okay, letter E. Got another one we have to do the conjugate for, and you have to do the conjugate when there's a binomial in the denominator. So the conjugate of this one would be -8 minus 9i. -8 minus 9i. There's a bunch of i's in this problem. Okay, so that would give you -24i minus 27i squared over positive 64. -8 times -9i would be positive 72i, oh, not squared, just I. -9, that would be negative 72i. The last one would be negative 81i squared. Whew, there's a lot going on. Let's clean up this because we know they're gonna cancel. That's what the whole point is. So this would give me on top negative 24i minus, or minus 27 times I squared would be plus 27. And then on bottom, I would have 64 plus 81. So 64 plus 81, what is that? 145? Yes. So 145, and this is a plus 27. Okay, now let's split it up and put your I term second. So this would be 27 over 145 minus 24i over 145. Can I simplify either one of those fractions? Nope, you cannot. So this is going to be your answer. Okay, next problem. Try it. If you want to pause the video and try it by yourself, do it. So we're going to multiply it by its conjugate. So on top, that would give me 35i minus 42i squared over 25. I'm just going to leave the middle part out because they're going to cancel anyway. If you want to work it out, yes, do it, but I'm not going to. So this would be negative 36i squared. Let's clean her up. So we've got 35i plus 42 over 25 plus 36. So that would give me, what is that, 61 on the denominator. Now you just need to write it in the right order and break it apart. So this becomes 42 over 61 plus 35i over 61. All right, I don't think I can simplify either one of those. 61 is prime, so that will be it. Okay, now we have two binomials. It's okay, just go slow so you don't make any mistakes. So multiply it by its conjugate, just like we have been doing. So the numerator would be negative 48. Oh, now we get to FOIL. So that would be minus 32i. Well, that would be plus 6i. And then plus 4i squared. All over 36 minus 16i squared. I cut off the middle part. Okay, so this one's a little bit longer, and that's okay. So let's clean it up. So this will be negative 48. That would give me 26. Negative 26i. And then that would be minus 4 over 36 plus 16. Doing a lot of mental math today. That's all right. It's good for me. So negative 48 and negative 4 would give me negative 52 minus 26i over, that would be 52, I believe. Oh, this one's going to be able to simplify nicely. So I'm just going to break it out before we simplify it. So this will be negative 52 over 52 minus 26i over 52. So you might have already noticed that turns into 1, negative 1. Don't forget about the negative. And 26 times 2 is 52, so this will be 1/2. Okay, so our final answer for this one is negative 1 minus I over 2, or you could say 1/2. You could write 1/2 I. It's the same thing. So that would be your answer. Let's do another one like that. Oh, great. Now here we got a lot of negatives. I got to slow down. So 5 plus 2i. 5 plus 2i would be the conjugate. So negative 15 minus 6i minus 20i minus 8i squared all over 25 plus 10i. I don't need to do that part. Plus 10i minus 10i, so those cancel. And then minus 4i squared. So that would give me so on top would be negative 15 over negative 26i plus 8 over 25 plus negative 4, so that would be plus 4. Okay, so now we have negative 15 and 8 is negative 7 minus 26i over 29. I'm just going to break it apart. So negative 7 over 29 minus 26i over 29. That's your answer. Last problem. Ooh, this one's going to be funky. Okay, let's do the conjugate. So 8 minus 7i. 8 minus 7i. So this would give me 64. So 64 minus 56i minus 56i plus 49i squared over 64, and that cancels, minus 49i squared. Okay, so this equals 64. What's 56 plus 56? Negative 112. So it'll be negative 112i. That would become negative minus 49 over 64 plus 49. These are big numbers on this problem. So 64 minus 49 would be 15. So positive 15 minus 112i. And then that would give me 113. Yes, 113. Okay. And now break it apart. 15 over 113 minus 112i over 113. I don't believe either one of those simplifies. I'm checking now. Nope, it does not. So this will be our answer. All right, I hope you had fun dividing complex numbers. Thanks for watching.